Hello everyone and welcome back after a long time, and this is our 17th video on our UPSC Civil Service question series. And let's start with today's. There are two questions are there. First question, I will write the directly given data and I will start to solve. So first it is 3 kg of air is compressed reverse stable in steady flow polytropic process. So mass is given 3 kg and initial condition is given P1. Initial condition P1 is given to us and temperature 40 degrees Celsius. So T1 is given to us. If we convert it, then it will 313 Kelvin, 2000 kilopascal. It is P2. During this process, law of compression followed is PV power 1.25. So N is equal to 1.25 polytropic. And so we have to determine shaft work, that means W, and heat transfer and entropy associated with this. So now one thing keep in the mind that for polytropic process, work as well as heat both can be negative or both may be positive. It depends. But in case of entropy, it may be negative, it may be positive, depending upon the process and this uh, n value. So let's start. So if you get the answer in negative, so please don't panic. So for work done, we know the formula mr t1 minus t2. Actually the formula is p1 v1 minus p2 v2 divided by n minus 1. But p1 v1 can be written as mrt, so mr common and t1 minus t2 is constant. Okay, mr constant and t1 minus t2. M is given as 3 kg, r value is 0.287 given, t1 is known, so we have to find t2. So how to find t2? So we know the relation t2 by t1 is equal to p2 by p1 power n minus 1 upon n, where n is 1.25. Put all those value, so you will get t2 as a 496 Kelvin. uh, Wait, yes, it is 496 Kelvin. Okay, now put this t2 value over here, and n is equal to 1.25, so you will get minus 630 kilojoule work done. Work done is minus 630 kilo. That means we have to give the work is given to the system. Now for heat transfer, we know the formula Q is equal to, for polytropic process, that is work done multiplied by gamma minus n divided by gamma minus 1. Work done we have minus 630, gamma value we have 1.4, and n value is we have 1.25. Put in equation and you will get Q is equal to minus 378.3 kilojoule, and this is negative sign indicate that heat is rejected. Now we have to find the entropy, so I am writing here over here due to space constraint. So delta S is equal to mcp ln t2 by t1 minus mr ln p2 by p1. Okay, we have m is equal to 3 kg, cp we can find cp is equal to cv plus r. Cv and r value is given, so you will get 1.004 kilojoule per kg Kelvin. T2 T1 we have, m value r value we have both the pressure ratio value, so you can find the entropy is minus 0.593 kilojoule per Kelvin. Here entropy is minus, that means entropy of this system, this piston cylinder where this compression is taken, it is uh, decreasing, but where we rejecting the heat this much amount of in atmosphere, so this atmosphere's entropy is increasing and more than this amount, so the entropy of universe will ultimately increase. But for polytropic process, entropy may or may be increased, may be positive, may be negative. So here we are getting answer as minus 0.593 kilojoule per Kelvin, so this is the correct answer. So now let us move for a second question, our today's and last question of equal friction method. How to we have to describe the equal friction method. So equal friction method is what? Uh, what in this method what we are doing, suppose this is a duct and we are designing duct in such a manner that suppose this is length is 1 meter. So for 1 meter length, the head loss due to friction is remains constant. Suppose head loss due to friction for 1 meter is 0.5 meter of water. So if we take 2 meter, so it will be multiplied by 2. Okay, so or if you take the half meter, that means it will become 0.25 meter. Okay, so this is the based on this. So in this equal friction method, what we are doing, first there is a main duct. In any air conditioning system there is a main duct, and there are some branch ducts are there which are coming in the room or as or wherever the air conditioned area. Okay, yes, so this main duct I'm writing with MD. So this main duct, the size of this main duct and the friction, it is decided based on the table. The table has the standard value from ASHRAE, American Society of Heating, Refrigeration and Air Conditioning Engineers. So ASHRAE, they have given some data, like we can say that what we can say that, like it is empirical relations. Okay, so from that we can find the main duct diameter. Then based on the correlation, like suppose the velocity we got in the main duct, so use this formula and use that velocity, and we will find out the friction coefficient of friction and head loss due to friction, and we will keep the head loss due to friction in such a manner that per meter length the head loss due to friction will be constant. Okay, and we have to design in such a way that the branch size will always be smaller than the main duct size, and this size of the duct is gradually going to reduce throughout the length, and the velocity it will be in such a manner that we will keep the cross section area in such a manner that the head loss will be same and there is no adverse pressure gradient, otherwise there will be cavitation effect also. So that's why we are making the taper area or continuously decreasing area in the direction of flow. So this will ensure us to prevent from adverse pressure gradient, and this is the most useful method, or we can say that mostly used method in industry. Why? Because it is easy, very easy to apply basic simple fluid mechanics funda, as well as one ductulator is there. It will, this software will do your all the some hectic work or complicated work, so you have to do very little calculation by yourself. So one thing that is that these are the advantages of this, and if we talk about disadvantages, so disadvantages is that if there is a short duct, like the duct is not too much long, so in this what we are doing, the noise, the problem of noise, when the air is coming at a very high velocity, then there is an issue of noise. So noise problem is there, and when we design the head loss, so we will take the only head loss due to friction, the minor head loss are neglected. Friction due to head loss due to friction, head loss due to friction is only head loss due to friction, the like FL v square upon 2 GD. So this is the major friction that is we are taking, but we are not considering as the minor losses. Okay, because this is the major friction, and in some cases the what whichever the longest branch is there, we are taking that friction also, and we are doing all our calculation, and we are determining the diameter of this branch duct, and what are the continuously gradually decreasing area. So this is the method, and here it is written all this thing over here. You can take a screenshot of it and you can just use this. So I hope you like this solution and today's question, and tomorrow we will meet with some new question. So thank you for watching this video.